Question 10 is coming from circles. The diagram shows the circle with center C, -4, 5, and radius root of 20 units. The circle intersects the y-axis at points A and B. The size of angle ACB is theta radians. Find the equation of the tangent to the circle at the point -6, 9. Now, when we look at this graph here, this diagram that is given, the center here is -4, 5. Now, if they are talking of -6 has to be on the left of the -4, okay? And then 9, so it has to be above this one here. So maybe it is around here, okay? So I can draw a line there. Maybe that is my tangent. And this one is -6, 9. And then this one is a tangent. So using circle theorems, we know that the tangent and the radius are perpendicular. Okay, they meet at right angles. So it is like that. Now I'm going to use these two to find the gradient of this radius. Okay, then after that I use m1, m2 is equal to -1. Then I will be in position to get the gradient of the tangent. After I have gotten the gradient of the tangent, I will be in position to find the equation of the tangent, because to find the equation of a straight line, you need the gradient and then one point through which it passes. Okay, so I'll begin by writing for a tangent to the circle, the angle between the radius and the tangent is 90 degrees, or in other words, the radius and the tangent are perpendicular. So let us use these two coordinates, -4, 5, and then -6, 9, to find m1, which is 9 minus 5 out of -6 minus 4. 9 minus 5, that is a 4, and then this one will be a plus here. So -6 plus 4, that one will give us a -2. So -2, that means this whole thing is a -2. And then that therefore means that the gradient, this is the gradient of the radius, okay? So gradient of tangent is now going to be -1 over -2, which is a half, because you know that for perpendicular lines, m1 times m2 is equal to -1, okay? Now, this line here passes through the point. They gave us the point is -6, 9. So -6 and 9. Now we are going to use y minus y1 is equal to m into x minus x1. So y minus 9 is equal to m is a half into, then this one is going to be x minus -6, so it will be a plus. Okay, and then when we open the brackets, this will be a half of x, then plus the 3. A half of 6 is 3. Then this one will cross, and then it becomes a positive. So plus the 9, meaning the equation of the tangent is going to be y, which is equal to a half of x, then plus 12. That is that. Then part B, find the equation of the circle in the form x squared plus y squared plus ax plus by plus c is equal to 0. Now, you know that the general equation of the circle is given by x minus a, bracket squared, then plus y minus b, brackets squared, then is equal to r squared, where the center is a B. Okay, now we have our center here, which is this one here, negative 4. So we shall have x, then minus 4, not so? But then this one is going to become a plus. So I'll just write x plus 4. Okay, x plus 4 squared, then plus y minus 5 squared, then is equal to, the radius is given as root of 20. So root of 20, then squared. Now we can expand. So expanding here, we shall put the square on x, and then 2 times x times 4, that will be 8. X, then 4 squared, that will be 16. Then here y squared, then 2 times y times negative 5, that will be negative 10 of y, then square the 5, it gives you 25. And then this one is 20. This one just cancels that. And then we bring everything onto one side. So you have x squared, then plus y squared. Then I can write 8x here, and then minus 10y, then plus 16 plus 25 minus 20 is equal to 0. So altogether, this one simplifies to x squared plus y squared plus 8x minus 10y, then 25 minus 20, that's a 5. So 5 added to 16, that one gives us 21. So plus 21, which is equal to 0. As simple as that. Part C, find the value of theta correct to 4 significant figures. Now, this one I can do it maybe in 2 ways. Okay? Let's check again what we are having here. Theta is here, but you can see that here the circle is meeting y-axis and also here. Okay? Then we shall have a triangle here. Of course, this will be a half of this length AB, and also this one is a half of this length AB. Why is it a half of it? Because this one is an isosceles triangle. This is radius, and then this one is also radius. You see that? So what we are going to have here, we don't know this distance here. Of course, this one now will be theta over 2, theta over 2. You see? Now, we need to get that length AB. Okay? We need to get those coordinates where the circle is intersecting the y-axis. You see that? Okay, now let's go back. And we say on y-axis, what do you know about y-axis? X is equal to 0. Now, when you go to this equation that we have gotten for this circle down here, we are going to put 0 wherever there is x. So that means we are going to have y squared minus 10y, then plus 21. Okay? So I'll come back here and I put y squared minus 10y plus 21, which is equal to 0. Two numbers, when you multiply them, they give you 21. But when you add them, they give you negative 10. That is a 3 and a 7. And both of them are negatives. So that when you multiply the two negatives, you get a positive. And when you add them, you still get this negative here. So we shall have y minus 3 and then y minus 7, which is equal to 0. So meaning this y here is equal to 3, and then the other one is y is equal to 7. So meaning the coordinates that we are having here, A here is the big y coordinate, so that is a 7. And then for B, it is the smaller y coordinate. So we shall have A, x is 0, then y is 7. And then B, x is 0, then y is 3. You see that? So what is the length of AB? Automatically, we just set 7 minus, because it is on the vertical, 7 minus 3. Or you can do it like this and you say 0 minus 0 squared, the change in x squared, then plus the change in y squared, 7 minus 3, then squared. Of course, now this one is a 0. Now this square root here is going to die with this square here. So your answer still becomes a what? A 4. Now, having gotten that as a 4, I will draw a triangle here. This AB, this is A, this is B, it is 4 units. So we shall have this one as 2 and this one as 2. I divide this one into 2. So I can have here theta over 2, even here theta over 2. The radius is root, because here we have C, the center, okay? The center here is C, root of 20. Now, I can use SOHCAHTOA, okay? There is also another approach I want to show you here. I can use SOHCAHTOA and I say sine of theta over 2, which is equal to the opposite here, which is 2, divided by the hypotenuse, which is root of 20. So meaning theta over 2 will be equivalent to the arc sine of 2 over root of 20. And then the theta becomes twice this one here. Okay? Root of 20. And then they want the answer to 4 significant figures. So what are we going to have? This one has to be in radians. Did they say anything about that? Yes, they said theta is in radians. You see this one? So your calculator has to be in radians. So my calculator here is in degrees, so I'll press shift, then mod, and then rad is 4. Now 2 arc sine of 2 out of the square root of 20. And then this one gives me 0.9273. 0.9273. Those are 4 significant figures. As simple as that. Alternatively, you could do it this way. This one here is a triangle which is not right angled, the whole of it. So I need to find theta here, okay? Already, this one is root of 20. So we have a squared, which is equal to b squared plus c squared minus 2bc cosine of theta, or cosine of A, okay? Now, we need this angle here. So, when I'm substituting, I'm going to have the A is the side that is opposite to the angle you are looking for, okay? So we shall have 4 squared, the whole of this, then is equal to, this is root of 20 squared, this one and this one, plus root of 20 squared, then minus 2 times root of 20, then again times root of 20, so I'll just put squared, then cosine of the angle that I'm looking for, okay? Let me extend this one a little bit here. Now, after that, I'm supposed to make this one the subject. So you will have cosine of theta. First of all, here when you square, you will get 20. Then also here, you will get 20. So I've brought this one this side, then take this one this way. Okay, so then minus 4 squared is 16. Now, when this one crossed this way, it becomes a plus. Now I will divide all through by this one here. So divide by, this is 2 times 40. Sorry, divide by 20. Because the square cancels the square root. So our theta is therefore going to be the arc cos of, this is 40 minus 16, that is 24, then out of 40. So what do we get here? The calculator in radians. Arc cos of 24 out of 40. Does it give us the same answer? Definitely. So that is 0.9273. 0.9273. 4 significant figures in radians. So whichever way you want. Then, but of course, to use this one here, you must have gotten this, okay? After here, then you can use this or you can use this, all right? Now, part D, find the perimeter and the area of the segment shaded in the diagram. So let's go back and check. The perimeter of this segment here, we need AB, which we have already gotten, okay? Then we need this arc here. Already we know this angle. You see that? So we are going to have perimeter. Remember, it is the sum of all the lengths around the shape. So perimeter of shaded region or segment is going to be equivalent to AB, the straight line, then plus arc of AB. Sometimes we put that, meaning arc. So AB is 4. And then you know that arc length is given by r theta. So the radius is root of 20. And then the theta, we have gotten it as 0.9273. Okay? So altogether, what do we get when we write the answer to 3 significant figures? 4 plus root of 20, then root of 20 times 0.9273. So we shall have 8.15. 8.15. Okay, this will be 3 significant figures. Okay, you don't need to put centimeters because they didn't tell us of any unit here. It was just in units. Okay, so just leave it like that. Then the shaded area. Shaded area. Of course, area of the segment is equal to area of the sector. Area of sector. That sector is ACB. If you can check here, ACB. So the sector is this one here. Then we shall subtract this triangle here. Okay, we take off this. So SCB, then minus area of triangle SCB. Now, here we are going to have area of a sector is given by a half r squared theta. Now, a half r is root of 20 squared. Then theta, we have seen it is 0.9273. Then minus a triangle which is not right angled. You just need to get this length here and this length here, then the angle in between. So it is going to be a half, then AB, sine of the angle in between. So that will be a half times. Now, the triangle here, you can see that this is actually root of 20, and then this is root of 20. So root of 20, then sine of that theta. So root of 20 times root of 20 sine theta is 0.9273. Okay. Now, we can simplify this one here. This one will give us 20 over 2, that will be 10. Now 10 times this one, it will be 9.273. Then minus, this one is also going to be 10. 10, then sine 0.9273. Remember, the calculator has to still be in radians. Now to three significant figures, what does this one give us? 9.273 minus 10 sine of 0.9273. That is 1.27. 1.27. These are square units, but to three significant figures, that is the answer we are supposed to have there.